and see if it will complete to the finish. What you will learn. Well, you'll be building a maze. So basically you are covering the engineering aspect, and then it's brain power. You have to complete the maze, so you have to think which piece goes where.
Right here is our SolidWorks model. Keep in mind right now it's a little bit generalized. There's a lot you can be doing with this. These are just kind of like sample pipes of people putting up, sticking to the board, because you can remove them as you please. But we also want to include maybe some curves, some pipes that have some bends on corners, just so it doesn't get a little monotonous doing that over and over again. Next one. As far as our target audience, I feel like a lot of people like it. There's not going to be a specific group, but if there were to be one, younger children, I think are going to get a kick out of building this, just because it's pretty easy to dismantle and put back together. You kind of got the idea from the gear exhibit you guys had there, where everything had to be perfectly aligned for it to work. Our concept's the same with that. Everything has to align up on the maze for it to be finished. For our dimensions, we didn't really want to cut corners with it. The smaller we made it would have been easier to make it, so we want to go max size 4x4, just that way we can get the most out of the project.
For the parts, we need a sheet of plywood, and then we're going to put a fabric on it so the Velcro strips for on the pipes can attach to it. And then we're going to have the PVC, which is going to be attached to the Velcro strips. And then the kids will just place the Velcro strips on the plywood, so then they can just make the maze. And then we're not sure what kind of ball we're going to use yet. And then glue for putting everything together, like the fabric on the plywood.
Alright, as for the MATLAB portion, we're going to ask the user if how much they enjoyed it on a scale of 1 to 10, how many parts they used, and how long it took them to complete the maze. And for timeline, we're planning on using the first week after we get the check to purchase all our materials, and the next 2 weeks to begin construction, make any changes we want to make before the prototype is completed and before testing. And we're going to test at a while and make any revisions and prepare for the final demonstration.
So we started thinking about the safety. Pipes should not be poisonous, because these kids might do anything with the pipes. They might lick it, they might do whatever, and you don't want to end up with sick children. Pipes should be light in case they fall down. Moving the pipes from place to place should be safe for the kids. So we were also thinking about this process. So we had to look for light pieces. We have to look for lasting pieces to decrease the running cost, to decrease the maintenance cost. So we found that PEX pipes are the future pipes, since they are developed by industrial engineers. They can resist thermal changes. We recognize you guys have water in the WOW exhibit. Iron board or magnets could be our plan B instead of using wood, so it would be safer to move the pieces from place to another. Using plastic traps is also possible for better self-control. PAX has every single color once you order it 6 months before the project is due. We also found the expenses. PAX has less expensive than any other metal tubes. So supplyhouse.com guarantees the lowest price for PAX, since they are the biggest provider on the East Coast. PAX with different diameters from 1/2 inch to 10 inches. They come with 40 different sizes. We also thought about having sensors at the bottom and at the start of the maze, so it would notify every time the ball makes it. Looking through that and searching for different kind of sensors, we found that the sensors used for water levels could be really good for that. They're really light, they're not dangerous, they're easy to program through C++ or MATLAB. So as we were hoping, the final exhibit is going to be having transparent tubes, so you would see the ball coming through, and it will also have light sensors, so the light would walk with the ball all the way down. According to Daily Mail UK, we found that CFL and some type of LED lights really dangerous to use in children's museums. So we were thinking about using the light LED lights. We will also use the balls you guys have in the exhibit, because it's safe and there's no way to eat it. Any children could play with it, whatever age they were.
Anyone have any questions?
It sounds like a Sounds like you guys have really thought this through. You've clearly done your research on the poisonous pipes, so that's good to know. I guess the one thing that I'll say is like Velcro can be really difficult to pull off and move around for kids.
You know, we were worried about the wear as well. You know, as far as sticking it on, pulling it off, how
Yeah.
well would it work over time? It's another problem we were thinking about.
Yeah, it's just something that you need to engineer, but a little bit of Velcro goes a long way.
Yeah, that's why we added a packing to it.
Got it?
PEG piping.
What's that?
With PEG piping, it's going to bend all the time because it's very durable, but also bends. I've been using it for a long time with construction. You're going to have to find a way to keep it either straight, or you're going to have to find a way to keep it bent because it will always try to bend in different positions.
Well, I think for our purpose, bending isn't going to be the worst idea unless it were to bend to the point where it's going to stop the ball from going towards the bottom of the mace. Because even if it bends, someone can adjust the next piece to fall in line and back
We
up.
also could not use PVC because we had the safety as the first priority in our project.
Thanks, guys.